If there are no stars, there won't be any beauty in the sky.
Pardon?
If there is no difference of opinion, there won't be any creative and innovative ideas.
Okay. Come
Honorable Chief Guest of the Day, Ms. Girija Muraleedharan, renowned guests, delegates, and all the participants. Good evening to every one of you here. I'm Rosemary Johnson, and I'm honored to welcome you all to the 68th Intersociety Weekly Webinar series jointly organized by IEEE Kerala Section, the Institution of Engineers Kerala State Center, Computer Society of India, Trivandrum Chapter, Project Management Institute, Kerala Chapter, Internet Society, Trivandrum Chapter, Vakkom Moulavi Foundation Trust, Trivandrum, Life Member Affinity Group, IEEE Kerala Section, IEEE Engineering in Medicine and Biology, Kerala Chapter, the Institute of Electronics, Telecommunication Engineering. Failure will never overtake me if my determination to succeed is strong enough, was quoted by Dr. APJ Abdul Kalam, who was born on 15th October 1931 at Rameshwaram, was a world-renowned Indian aerospace scientist who contributed to the technological development of the country while working in ISRO, DRDL as well, while serving as the 11th President of India from 2002 to 2007. Generations to come will be inspired by his thoughts. In addition, he was such a wonderful human being. He was also a wonderful teacher. The 27th of July marked the anniversary of his passing. On this occasion, let us all remember this wonderful spirit who tirelessly and unwaveringly strove to build India. In his honor, let's dedicate this lecture to Muslims of India. To ignite us on 3D printing in industry, we have the distinguished speaker of the day, Ms. Girija Muraleedharan, Director of Cloud Design Service, SprintRay, US. Being delightful, I would like to call upon Ms. Adulya, IEEE student member, to deliver a welcome address. Please do the honors.
Ladies and gentlemen, greetings to one and all. Myself, Atulya Ullas P from IEEE EMBS Kerala Chapter, is assigned with the task of welcoming all of you who have joined with us for today's talk. It gives me tremendous contentment to present the welcome speech amongst the most esteemed personalities. I extend a warm welcome to all at the 68th talk of Intersociety Weekly Webinar Series. This great venture, initiated by Intersociety, has been successfully coordinated throughout
Am I the only one who cannot hear Atulya?
No, she's not audible.
Okay.
Rosemary, you can take over and complete the task and go ahead.
Yeah, okay, sir. On behalf of Intersociety Weekly Webinar 67th series, I would like to welcome all to this occasion.
is not an exception. So today, I find immense pleasure in introducing our speaker, Girija Muraleedharan, Director, class sharing with
Sorry, sir. Sorry for the intro. Are we good to go, sir?
Yes, go ahead.
Okay. So I welcome you all to this occasion. Being delightful, thank you, Ms. Adulya. To give an introduction concerning the renowned speaker, we have Ms. Amina, IEEE student member. Over to you.
Good evening. Am I audible?
Yes.
Yes, you are.
A warm good evening to one and all present in this virtual gathering. I, Amina, deem it as my privilege to introduce our illustrious speaker, Ms. Girija Muraleedharan. Ms. Girija Muraleedharan is the Director of Cloud Design Services at SprintRay, a company focused on digital dentistry and 3D printing. She graduated from the College of Engineering Trivandrum in 1992 with a B.Tech in Electronics and Communication Engineering and holds an MBA from Mackay University. She's a seasoned executive with a flair for taking on ambiguity and risk and a proven track record of significant impact in a professional career spanning 25 plus years. She has a never-ending impressive profile starting as a software engineer in Wipro Technologies from 1992 to 96, and in Metamont as project manager from 96 to 2001. Ms. Girija also led the delivery of several multi-million-dollar initiatives for investment products and institutional investments as the project manager of Northwestern Mutual from 2002 to 7. She has also proven her excellence as the general manager of USP Global from 2007 to 2011, and also led IT delivery and customer care for Suntech Business Solutions. She was also the head of strategy at Northwestern Mutual from 2014 to 17, and also the director of customer experience at National Life Group from 2017 to 20. She indeed is a demonstrated versatile who has proven her excellence in handling different types of roles, from frontline business leader to business success enabler to operations leader. It is my pleasure and privilege to welcome you to the 68th talk series of the Intersociety weekly webinar series. Once again, wholehearted welcome, ma'am.
Thank you very much, Amina. That was a very generous introduction. Thank you. Shall we get started with my presentation?
Please.
Okay. I'm going to share my screen. All right. So 3D printing and digital dentistry, and I didn't realize that Amina was going to do such a wonderful job of introducing me. So I had a slide about myself, a little bit about myself. But Amina said all these things. The only thing that she was not able to say was that today I live in Burlington, Vermont, and also that this is my family. My husband Krishna, my daughters on my left is Geeta, and on my right is Tilly. Geeta is 23 years old. Tilly is 17 years old. So this is my family. So to answer the question earlier about who is SprintRay, what does Girija have to do with dentistry? So SprintRay is a technology company that focuses on end-to-end 3D printing solutions or ecosystems for dental professionals. So which means that while the company started with selling 3D printers, it has expanded. The company has expanded to a whole range of solutions. This picture is some of the things that we have. And just a little bit of history of SprintRay. SprintRay was a startup established about 5-6 years ago in 2015, and started with 3D printing. And 3D printing companies in the 3D printing industry generally, they don't have a focus on one industry. They produce 3D printers that you can use for pretty much anything. And so SprintRay in the beginning was also like that. So, we were into jewelry, we were making parts for Disney, we were doing things for Lockheed Martin, aeronautics industry. But then there came an inflection point where, do you want to be the jack of all trades, or do you want to focus on one industry? And dentistry is something that caught SprintRay's attention. Dentistry being a fledgling technology area, and realized that there were a lot of applications for 3D printing in dentistry. So the company decided to focus on dentistry, with the result that SprintRay is the only company that focuses on digital dentistry, and it focuses on an end-to-end solution for dentistry. Any questions? Okay. So what is 3D printing? So today in this session, what I'd like to go through is kind of go through the technology of 3D printing and how it's used in dentistry. What is digital dentistry? And then I'll show you some of the things that have been 3D printed for myself also. So 3D printing, you print a 3-dimensional object from a CAD model, And the key is this using by successively adding material layer by layer. So you print one layer of the image, then you go up, you print the next layer, and you keep printing layer by layer until you have your entire image printed. And that's why, because it adds layer by layer, that's why it's called additive manufacturing, as opposed to traditional manufacturing, where you start with a big block, one big block, and then you shave it, you chip it, and turn it into the shape that you want to print, which is reductive manufacturing. But 3D printing is additive manufacturing, because you add materials layer by layer. Some of just some pictures of some items being 3D printed. And of course, our Yoda. So how does 3D printing work? So 3D printing, so in this picture, so this is a picture of a printer, and you have this thing that is the platform. So this is the platform on which the image, on which the final item that will be printed will be, you'll get it. And then this is a tank of resin. So this is the building material. So what happens is, the platform comes all the way down to the level of the resin, and then it prints one layer from the resin. So it cures basically through heat. It changes the material properties of the resin and in the shape that we need it to be in. Then the platform raises itself up a little bit and prints the next layer, and so on and so forth, until the entire thing is printed, and then the platform will come back all the way up. That's how 3D printing works. So the different types of 3D printing. The first one is DLP, which is digital light processing. DLP is where you use a light projector, to project an image of that layer that you want printed. So in one flash, that entire image is projected onto the resin and the platform, and then it prints that layer. So because this entire image is projected together in one shot, the DLP printers are generally faster than others. But then, similar to this one projection thing, is the LCD printer. So the LCD printer has a screen which is not unlike our phone screen, similar to a smartphone screen, and it projects again the entire layer at once to the LCD screen, so that it can be printed. The problem, the slight problem with LCD printers is that the light source, the light source is something that needs to be replenished, and the light also affects the LCD screen affects the properties of the resin. So it's a little more difficult to figure out exactly what resin you can use. And the third one is a laser printer. It's also called an SLA printer, and in this one, a pin dot of high intensity. This light here, a ray of light here, keeps going back and forth and draws the image of that one layer that you want printed. So this makes it a little slower, because with each layer it has to go through the entire platform and draw the entire picture, so that the image can be captured. So these are the three types of 3D printing: DLP, digital light processing; LCD; and laser printing. The SprintRay printer. SprintRay printer is a DLP printer, is a light projection, digital light projection, excuse me, digital light projection printer. Excuse me. So we have our own patented projector that we use, and this is how the image falls on the platform. This is what the 3D printer actually looks like. It has a big case inside it. At the bottom here will be inside this is the projector, and it beams onto the platform. And then the big case, and the case can be opened so that you can access the resin tank, access the platform, etc. So at SprintRay, we have two different types of printers, Pro 95 and Pro 55. So the Pro 95, you'll see, the first one is the 95, and this is the 55. The 95 has a 95 micron accuracy, and the 55 has a 55 micron accuracy. And the 55 micron accuracy, so that is the more accurate printer, because it can print in that thickness. 55 micron thickness is each layer. Just for comparison, a strand of hair is about 20 or 25 microns, and this prints, each layer is a 55 micron layer, and it becomes more accurate. When you look at it, the difference between the 95 and the 55 is in the platform size. You see that this platform is larger, and the 55 platform is smaller. And the easiest way to understand that is to kind of think of a projector, right? A projector, when you bring it closer to the wall, or when you increase the resolution of the projector, it becomes really better. You get better resolution, but the image on the wall becomes smaller. And that's why, as the resolution increases of the projector that we have inside the printer, the platform size, the area of the image it projects becomes smaller as the resolution increases. And that is why you'll see that in the 55, on the Pro 55, the build plate, the platform, is smaller than the Pro 95 platform. So why dentistry? Today, in the age of artificial intelligence, we see that 90% of dentists, they use 100-year-old fabrication techniques. So, for example, all of us have been to dentists, and they put this god-awful material inside your mouth to take an impression. Then you have to, somebody will be hand carving, if there are any appliances, if you need a crown, if you need braces. Somebody is hand carving all those things in here. It's messy and it's wasteful. Like my daughter was saying yesterday, it's just plain disgusting. What they put in your mouth. It's cumbersome to store. Look at these packages, right? It's a very antiquated way of fabrication and manufacturing. And then that brings us to digital dentistry. So when you go to digital dentistry, it all begins with a scan. So instead of that material, that goo material that they put inside your mouth, and then they have you bite down to take an impression. Basically, what they're doing is taking an imprint of your teeth, so that they know how your upper arch and your lower arch are positioned, the topography of your mouth, how the teeth are placed, etc. They're taking an impression. Instead of that, you can use a scanner to take an optical impression. So you just run the scan through your mouth, and you have an optical impression, a 3D image of your mouth. So without any of that messy thing that they place inside your mouth. So you scan it, and then you can design your what we call appliances. So in dentistry, you go to dentists for cleaning. Sometimes if a tooth cannot be saved, and if a tooth needed to be removed, but then for aesthetic purposes, or just to help with chewing, you put a crown on it. So this crown is an appliance. It is not your original tooth. It is an appliance. So you could have a crown. Sometimes you have this thing called a bridge, which is 2 or 3 crowns together, attached together. So it's like, one piece, and that is another appliance, a bridge. Dentures for people that don't have any teeth, dentures, so that is another appliance. So any of these things that go from that are not naturally in your mouth, that is a third-party fabricated thing, that is an appliance. And every appliance that goes in your mouth, that has to be designed for your mouth specifically, for your topography specifically. And that's why after you scan and you get that impression, you need to go through a design phase. You need to somehow figure out what these appliances that you need to place in the mouth, and you need to design it. And once you design it, you can print it. So now you have, after you design, you have a 3D printed model of that crown or the bridge that you want to place, and then you can 3D print it. And after you 3D print, there's a couple of post-processing phases. So what I'd like to do in the next few slides is sort of go through this process and go through each of these steps. So the scanning. So the term for it is an intraoral scanner. Inside the mouth, intraoral scanner. There are many different types of scanners available in the market. 3Shape. These are some of the most popular scanners. 3Shape Trios, Primescan, Itero, Planmeca, and Medit. Some of the most popular scanners. And this is what it looks like. It's basically a handheld wand that you can, and like the picture shows, that you can put inside the patient's mouth and just run it around the mouth, and you have the optical impression, the image of the teeth. One thing to note is that it is not like an X-ray. It is not invasive. Nothing goes inside. It's just light being beamed onto inside your mouth. So there is no harm done to the patient, no radiation or anything like that. So that's the scanner. So once you scan, like I said, now you have an impression of the mouth, and excuse me. You have an image of the mouth, and you can design your appliance. You can design the appliance that needs to go on this patient's mouth. So for that, to design it, you could use design software. So these are 3Shape and ExoCAD. These are two of the most popular CAD software that can be used to design these appliances, and these are very sophisticated softwares which need some level of expertise to work with. There's another one called D3 Splint. A splint is basically like a guard, a night guard, and it's interesting. Just an anecdote. In the last year and a half, because of COVID, this time has generally been, and we will all understand this and relate to this. This time has generally been a high anxiety time for people, for everyone in the world, and this high anxiety has translated to a lot of when people sleep, a lot of grinding of the teeth. And when I see my mother, hi Emma. Okay, a lot of grinding. This results, this high anxiety has resulted in a lot of people grinding their teeth in their sleep. So meaning clenching the teeth, and it's just grinding. And the result of this grinding is a lot of wear and tear on the teeth. So something that a lot of dentists have had to prescribe in the last year and a half is called a night guard. A night guard is it's kind of like a plastic shell. But I say plastic, it looks like a plastic shell. Kind of, it's a shell that you can put on your teeth, and then it's like this, right? Basically, it protects. It forms a barrier between your upper arch and your lower arch, so that you don't, even when you're clenching, you don't grind your teeth away. And so you're a few years down, you're not going to have a chipped tooth. You're not going to prematurely lose your teeth. So D3 Splint is a software that specializes in these things called night guards, and DentalCAD is also another software. So this is an option for that second phase, to design an appliance. A doctor, a dentist, or staff in the doctor's office can use one of these design software and design the appliance that they want. Now this, like I said, is a little time consuming. So you have other options. You have other options like design services. And this is where at SprintRay, this is my primary responsibility. I lead the cloud design services business line for the company. So in design services, what you can do is that scan that you took of the patient, that you can just submit to a company like SprintRay that provides design services and tell them, oh, for this scan, for this patient, I want to make dentures, or I want to make a night guard, I want to make a crown, whatever. You give the input files and you specify what you want, and then boom, this platform will design it and provide the designed appliance back to you. We call ourselves, Cloud Design, and this is our new logo that was designed just a few months ago. You might recognize some of the names on this. You might not recognize some of these names, but yeah. So this is a screen that I use to demo usually. So now we're in the second part. We finished scanning, we finished designing, know how to design, and now the printing. And we talked about the printing aspects. What we did not talk about was the resins. So the resin is this, because this is material that needs to go inside a person's mouth. Obviously, the material can't be just, I don't know, plastic, that stays inside the mouth for years on end, right? So this is material that has been carefully developed. So SprintRay, we've developed our own materials, and these are some of the materials we've developed. And based on the appliance, the kind of material also changes, because different appliances have different pressures applied on the appliance. So different material strength needs to be there for these different appliances. So you'll see that for the different, like surgical guide, you have one kind of resin, and for splint, like I said, the night guard, you have another kind of resin, etc. So we have, so these are some of the resins we build, and in that, that first slide that I showed of how 3D printing works, in that resin tank, you pour this resin, and then it gets cured to form the 3D image. Post processing. So once you get the item out of the 3D printer, there is still resin on it. It's a little sticky, so that resin needs to be washed, and you don't wash it in just water. It needs to be washed in IPA, isopropyl alcohol, and it generally needs 2 phases. One, two-stage washing. One where that alcohol gets a lot more dirty, and then it's like the nice rinse phase. The second rinse phase is where with cleaner alcohol, you wash it again, and then you have to, and then it's dry. I'd like to show a video of how the wash works. I'm going to try, hopefully you have to let me know if you can hear and see it. Let me start from the beginning.
There's no audio.
It's coming. It'll come. So actually, I want to pause here, and if you see how it was. So this was the print. This is the printer. She's taking it out of the printer, the platform from the printer, and then you can put it inside the wash. And you start it, and now we'll see how the wash happens. take it out of the wash, and then now it's all washed and dry. So that was the wash. So basically, you have a propeller at the bottom, and it's the alcohol comes into the wash chamber, and the propeller spreads the alcohol all over, so that it gets a really good clean wash. The thing is, doctors earlier, before we had this wash, the doctors would, after the 3D printer, they would have, I don't know, 2 small steel bowls, 2 small, Tupperware bowls, they'd have this alcohol in there, and they would take the printed item, and then wash it first in the in one bowl of alcohol, then take it over to the next bowl of alcohol. And this is alcohol, there's the resin is messy, it's sticky, it may get on your clothes, that whole area becomes really messy, all those things. So in the beginning, people were like, oh yeah, it's fine, we can do it. But the thing is, it's okay to do it one time. It's okay, when you have 2 bowls of alcohol and you're doing it once. But then, when you have a lot of things that you're printing and you're doing it all the time, with these 2 bowls, then it becomes very, very old very quickly. And that's why, this product has been really appreciated by the doctors, and it's just flying off the shelves ever since we came up with a wash. So after the wash, then you cure it. You cure it so that it hardens. The appliance that you've printed hardens. And curing is basically, it looks like a little microwave. Microwave, with a door in it, and it's 90 watts of power from 10 sets of LEDs that are in either side. And the surface inside is a multi-directional reflective surface. So that heat goes all over, and it helps it harden. And inside it's a convection heating chamber that helps the appliance harden. So once this is complete, the curing is complete, now the item is, you would think that the item is ready. It's actually not completely ready. Now, when you take the item out, so the thing is, so remember, like we said, 3D printing means that you are printing layer by layer. You're starting at one layer and you're printing layer by layer. What if there's an item that is sort of at an angle, like a cantilever, right? And so let's assume this pen here, you're printing. It prints this. It can, when it prints a layer, it can't just print it in mid-air. It needs gravity, right? You can't just suspend and print something in midair. So what you need is, you need to have supports. Otherwise, you just can't print in midair. So these things, so supports need to be added to the print job. So when you get it out printed, it'll have all these supports. And this orientation is also very important, because there's just different orientations can affect the way they are printed and can affect the fit of the appliance. So orientation and the sprints, very important during 3D printing. And this is just a few other images of 3D printed items. And once you're complete with the curing, then you take some flush cutters and you can snap these supports off fairly easily. And then you can polish them, especially because it's going in the mouth. It's very tender skin inside. Any little aberration, may cause irritation. So after you cut the supports with the flush cutters, you need to polish it just a little bit. Can you guys see me, or should I stop sharing, because I want to show you a couple of things? Can you see me?
We can see you. We can see you.
Okay. So I want to show you some of the things that were built. So let me see. Okay, so this one. So this is a model, a tooth model. This is actually my tooth model. So I took a scan of my mouth and printed this model. And I was talking about the night guard, right? And so we made a night guard for myself. So this would go in like this. So this is a night guard made from SprintRay's resin. It was designed by my team and printed on a printer, 3D printer. So you see, it is nice and smooth, and there are no signs of supports. But when it came out of the curing, this is what it looked like, because it has to be oriented at an angle of like 30 degrees before it so that it prints well. So that's why you see this angle, and you have all these supports, and then you take these supports off, and you end up with a night guard. Another thing that I want to show, that's something that was printed on our 3D printer, is this denture. So this denture arch. So this denture is how you print it is, you print it in two pieces. One, first you print denture, and then next you print the teeth or the dentition. And then with the same resin, so when you print the base, you basically have hollows for the teeth, in the base. And then you can put a drop of resin in those hollows, and you can put the dentition, put the teeth in there, and you can bond them together to form a denture. Okay. So that's on the orientation, supports, all the items. And now I want to go into, okay, so the business. So this was, basically the process of 3D printing. And is there really a market? What is the market? So just very briefly, right? The global market is the dental products market is a $23 billion market. There are some established companies here, like companies like Dentsply Sirona, 3Shape. These are some established companies in the dental market, but they are, just like established companies, they're not really thinking about these innovations and how to change it. And that's why there is space for disruptors like SprintRay to come into the ecosystem. In the United States, there's about 165,000 active dentists. So we market our products mostly to clinics, to dental clinics. So there's 165,000. But you'll remember, you can't have 3D printing in your clinic unless you have a scanner, right? Because like I said earlier, that's where digital dentistry begins. You have to have a scanner. And the scanner, I don't remember if I mentioned this before, the scanner, it's a little pricey. It ranges in price from $10,000 to, it can go all the way to $40,000. So of this 165,000 dentists in the United States, only about 50 to 60,000 have scanners. So that is the market that 3D printing companies like ourselves go after. The dentists that have 60,000, there's 50,000 dentists that have a scanner. Orthodontics. So orthodontics is anything to do with teeth movement. So the braces, the clear aligners market. And these are just different areas within dentistry. So basically a pretty big market. Let's look at India. India has 1.7 million dentists, comparing that with the United States, which has 165,000. 1.7 million dentists, 50,000 of which about 50,000 are specialists. There's apparently, there's about a 20 to 30% growth in dentistry in India. But still, even with 1.7 million dentists, in the urban areas, the dentist to patient population is 1:9,000, which becomes, by an order of magnitude, by a couple of orders of magnitude higher when you get to rural areas, 1:200,000. And there is also, in India, we have dental tourism, where people from other parts of the world, other countries, come into India for the lower cost dental work that can be done for them. So that is the market. But what is, why would doctors go to digital dentistry, go to 3D printing? So I want to give an example of clear aligners. So clear aligners, basically, you know this first picture. We are all familiar with this, braces. Our kids, or when we were young ourselves, we had braces. So that orthodontic treatment, right? For teeth movement, you use braces so that you have a beautiful smile. Well, in the last few years, Invisalign, a company, pioneered this technique where instead of this ugly-looking metal steel braces, you have these clear plastic things that look like plastic, clear items, clear. It's called an aligner that it's a tray. It's an aligner tray that you can just fit on your mouth, and that brings about the movement of the teeth, just like the braces did. So clear aligners. So this is a huge market. And this is why that orthodontic market is also pretty big, because of the clear aligner market. So if you look at the prices. So in the US, there are companies like Invisalign. Like I said, Invisalign pioneered this way of clear aligners. Invisalign, SureSmile, Candid, these are companies that provide clear aligners. And the cost is anywhere between $3,000 to $7,500 based on how much movement you need. Again, based on how much movement you need, the number of trays. Sometimes, you need only 2 trays or, 5 trays. Each tray lasts in your mouth for about 2 weeks. And then after 2 weeks, you take it out, replace it with the next tray. And that handles the next set of movements that the dentist wants to effect in your mouth. It costs about $3,000 to $7,500. What about in India? In India also you have clear aligners. There are companies like 32 Watts. Invisalign is established in India. Snazzy Align, and these cost for the I think Snazzy Align gives it for 50,000 rupees, but generally it can go up to about 3 lakhs. Now, if you look at 3D printing, clear aligner is something that in the office the dentist can print, and the cost to the dentist is about $250. Okay, so there is a huge price differential, and there is a huge potential to drive the prices to patients down for dental products, and that's why SprintRay is in this business. SprintRay believes, we believe that technology has the power to transform every dental practice, and our mission is to accelerate this transformation and make dental care affordable and accessible to everyone on this planet. And that brings me to the end of my presentation with 2 minutes to go. Any questions? Anything I can clarify for you?
The section was informative, where we learned a great deal from it. We have some questions in the chat section. Ma'am, are you good to go with the questions?
Yes, absolutely.
Okay.
Let me stop sharing.
Okay, ma'am. Okay. The first question is that please indicate the cost of SprintRay printer.
Please indicate, I'm sorry?
Please indicate the cost of SprintRay printer.
The course?
Cost, the price.
Oh, the price. Yeah. So SprintRay printers are generally about $6,000 to $7,000.
Okay, ma'am. So the next question, what is the approximate cost of one pair of upper and lower jaw teeth? What is the lifespan of the artificial tooth pair? Any non-after effects of their use?
So when we say one pair of upper and lower jaw teeth, so a denture. Oh, I'm showing the denture. Yeah, you can see it. So a denture. So I'm assuming that this is what we mean. So generally, in the United States, to make one set of dentures, an upper arch and a lower arch, generally the price is about $3,000 to $4,000. So to a patient, and the cost to a dentist to make this, because like we said in the beginning, normally they have to take an impression, they send instructions, they send it to a lab, and the lab will take a week and a half, 2 weeks to make the denture and then send it back, etc. So normally, the cost to the to the doctor is generally about, I want to say about $1,000. But then, you know, when you're 3D printing it, you can print one arch of a denture for less than, design it and print it for less than $100. And the lifespan of the artificial tooth, and this is very interesting. So the dentures, dentures, you know, they will last a long time. But then what happens with, you know, if you're asking about the lifespan of dentures, what happens with dentures over time is that our teeth, you know, this is something that I didn't realize, you know, until I started at SprintRay. Apparently, our teeth are in constant motion. They're constantly moving. So if you take a scan a year ago, and you take a scan now, you'll see that the scans are different because our teeth have moved. So because of that, dentures over time, you know, and obviously a denture is not going to move, right? So, what people who wear dentures, they will come back in generally about 4 or 5 years because the dentures have become too loose, or you know, many times, you know, it's discoloration in the dentures, etc. So it's about 3 to 5 years. Not for 3D printed, you know, for any kind of dentures. It's about 3 to 5 years when people generally need to replace their dentures. And interestingly, also in the dentures market, about 90% of dentures are what we call a copy denture or a reference denture, where basically there is, you know, the patient already has a denture. And you're just copying the denture. You're just making a copy of it, making a new set to fit the patient a little better. Any known after effects of their use? So if it's dentures, no, not at all. You know, you take it out every day. You can take it out. For things like crowns, you know, those are permanent fixtures. Those are things that you attach, you cement onto your teeth. For those, you know, the FDA requirements are more stringent, and you know, we just have there is a resin, that was approved, you know, maybe 3-4 months ago by the FDA as a permanent crown, and that is fairly new. Truth be told, you know, for that permanent crown, generally the lifetime of a crown is about 7 to 10 years. A 3D printed permanent crown, and that is, you know, a permanent crown is usually made from ceramic, ceramic or zirconia, and a 3D printed crown will probably last about 3 to 5 years instead of the 7 to 9 years. But then, you know, the price differential, you know, for a ceramic crown which will be about $900, but a 3D printed Varseo crown would be about $150.
Okay, ma'am. Moving on to the next question. How much time it takes the wall process scanning to the final product a denture?
Yeah, so scanning usually takes about 3 to 5 minutes. Printing the product, depends on the appliance that is being printed. A denture can be printed in about 35 minutes. And the thing with the 3D printing platform, you know, because it's a big platform in a dentist's office, you know, they don't need to print just one denture, you know, so they have multiple patients coming in. So they will print maybe 4 pieces together or maybe 6 pieces together. The platform is large enough to hold 6 pieces. So you know, whether you're printing 1 piece or 6 pieces, it takes the same amount of time. So printing takes about 35 minutes. The wash takes about 3-4 minutes. And the curing takes another 15 minutes. So it's 35 plus about, you know, let's say 20, so about 55 minutes. 55 minutes for the entire printing, and then probably another 5 minutes to take out the supports and polish the appliance.
Okay, ma'am. Does 3D printing has application in dentistry only? What about the other sectors?
Absolutely. 3D printing 3D printing has many applications. It just so happens, like I said at the beginning, that SprintRay as a company, we focus on dentistry. An interesting story, our founders, so the founders of SprintRay, they're three very young people who are PhD students in the University of Southern California, USC. And they were doing their PhD in additive manufacturing, and they came up with a printer, and they decided to do a Kickstarter campaign. And let's see. And they wanted to raise $100,000 and see if there was any interest. And they ended up raising $500,000, and this was back in 2014. And so basically orders, right? So people come in and order this, and they were able to raise $500,000. And they found that Lockheed Martin, they ordered a printer from these, PhD students, young 28, 30-year-old kids, who made this printer. They placed an order. The Lockheed Martin placed an order. Glidewell, which is one of the huge, the biggest dental companies, they placed an order. Disney placed an order. Jewelry companies placed orders. So in the beginning, you can make aeronautic parts. We made a lot of figurines, Lion King figurines, things like that for Disney. So definitely 3D printing has applications beyond dentistry, but we are focusing on dentistry because that allows us to focus not just on 3D printing, but the entire workflow and manage our resins, manufacture resins that are suited for 3D printing of dental appliances versus things that, like you're making a Lion King figurine.
Okay, ma'am. Moving on to the next question. What are the 3D printing advancement in biotechnology, organ printing, nano devices?
And these are all dependent on the resins. Resins that are available, the more invasive the product is in the anatomy of the person, the more stringent the requirements, the more obviously, right? Because these are things that will be inserted inside the body. So the more stringent the requirements on the material science of the resins. If you take aligners, for example, the 3D printing technology, right? Aligners, so I I just talked about how aligners can be made from 3D printing. The one thing that I did not mention there is aligners. The actual tray is not 3D printed. The actual, so what is 3D printed is the model. So the dentist says, these are the different types of teeth movement I want. So the first time, the teeth would look like this. The next time, some more movement and the teeth would look like this. So what the dentist prints is this model. So they print the model and then they do this vacuum forming. So, it's something like a little bit of a plastic sheet, maybe it's not plastic, but something like a sheet. You vacuum form it, put it over this, and you thermoform it so that, it comes out, and that is the tray. That is the tray that goes in the mouth. The reason for that is that there is no resin in the world yet that has the properties of that tray. We always joke that the aligner resin, clear aligner resin, that is the holy grail of 3D printing. Anybody, whichever company comes up, develops that resin, they are going to dominate the market. So I'm just using that example to illustrate how important and how dependent 3D printing is on the resins that are available and how stringent the resin requirements are, the more invasive the product is. I'm just looking at this. I'm looking at this message that says, I've been wondering how the clear aligners my niece is using is fabricated. So this is how the aligners that your niece is using are fabricated.
Okay, ma'am. I think it's clear. Then moving on to the next question. Polymeric resins are not very hard. Does these resins have inorganic minerals incorporated to make them hard? Is it a composite material?
This is something that I am not in the material science. I'm not in the resin part of the company. So I don't know the details. I know that these resins are photopolymer materials, photopolymer resins. There must be materials, there must be things incorporated in them to make them harden during curing. If you'd like, I can get some details and get back to you, but I don't know more about the resin material, unfortunately.
It's okay, cool, man. So moving on to the next question, any kind of pollution concern with this desktop resin 3D printers?
No. So the resin usage, resin doesn't come cheap. So one bottle of resin, for the night guards, right? So these are the night guards. So one bottle of resin, first of all, can make about 100 such night guards, and one bottle of resin is about $400. So it doesn't come cheap, and this is resin that is that will be used up by the doctor, and we are very careful. We have detailed instructions about disposal of material that is leftover material, whatever that is not being used, because we obviously want to be concerned about the environment. So there isn't a pollution concern with resins.
Okay, ma'am. Going to the next question. Is it possible to use non-plastic materials in 3D printing now? When will it be possible to use zirconium, etc.?
Yeah, zirconium. So like I said, that crown material, right? Crown material, normal 3D printed permanent crowns are made from zirconium or ceramic. There is no resin yet. The one that is closest to zirconium is this Varseo resin, Varseo's crown and bridge resin. But it's still not zirconium. It still does not have the pressure withstanding powers of zirconium.
I think that was our last question. Sorry, ma'am, we got one more question. Given the high cost of the scanners, are they available on rental basis, or it has to be purchased especially if varied scanners are needed?
Excellent question. Very business-minded question. So, one, you don't need multiple scanners. So, when I had that picture of all those different scanners, I wasn't implying that one clinic would need multiple scanners for different things. You just need one scanner. So that's one. But yes, the price is high, $10,000 upwards, and even the printing suite of machines of equipment as well. The printer may be only 6,700, but everything together, is about 12,000. And we are a well-priced 3D printing company. So one of the things that many companies are doing is coming up with the subscription model, where, I don't know, for $300 a month, $200 a month, if you'll commit to 3 years, you can get the entire suite for $300, $400 a month. So definitely, yeah, something we're doing for the business.
Hopefully that was our last question. We are almost done with the Q&A section. You have provided us with a trove of information, and we are grateful for the time you have spent with us. Gratitude is a fairest blossom that springs from the soul. So I welcome Ms. Bhagyashree, IEEE student member, to share wholehearted gratitude.
Thank you, Rosmi. Honorable Chief Guest of the Day, Girija Muraleedharan, respected dignitaries, guest delegates, and all the participants. I, Bhagyashree, feel it's my privilege to have been asked to propose the word of thanks on this occasion. First of all, a big thank you to our speaker, Girija Muraleedharan, for giving us such a great presentation on the topic 3D printing in the field of dentistry. She gave us a lot of insight into this topic through her words of wisdom and made this webinar a very interesting session for all. Thank you so much, ma'am, for taking time out of your busy schedule to be with us today and for gracing the session with all those knowledgeable words. Thank you, ma'am. Next.
You're very welcome. Thank you for having me.
Thank you, ma'am. Okay, so next, I would like to thank Harindra sir for your constant support and effort in organizing this event. Thank you, sir. I also would like to thank Atulya and Amina for being a part of this webinar. I also extend my sincere gratitude to IEEE and all supporting organizations and various crew members for your constant support in making this event a grand success. I must mention my deep sense of appreciation for Rosmi, the moderator, and the Zoom controller Sharon for effectively managing the session. Last but not least, I would like to thank all the participants for your patient listening and cooperation. Without you, this would not have been a successful one. Thank you and have a good day. Thank you, ma'am.
Bhagashri. The next webinar will be happening next Wednesday, 4th August 2021 from 6 to 7 p.m. It will be our 69th talk session and will be handled by Mr. Roy Kurian KK, Business Advisor for SMS Mentor for Business Owners on the topic Insights for SEME Business Owners and CEOs. There is no real ending. It's just a place where you stop the story. You're all welcome to join us next Wednesday. We look forward to see you again. I hereby announce that the meeting is officially dispersed. Much thanks to all of you.